Hello and welcome back to Introduction to Finance. Today we're going to be looking at annuity problems where the compounding frequency and the payment frequency match. So you'll notice I split this up into two different videos. In this first one, I'm only doing problems where those two frequencies are exactly the same. The reason for that is the problems are actually solved a little bit differently if the compounding frequency and the payment frequency are different. So the way I'm going to go through this is I'm going to go through one overall example problem, looking at the equation, where this equation comes from, what it calculates, and then we're going to go through two example problems past this. So the first one looks at annual payments with annual compounding, and the next example problem looks at monthly payments with monthly compounding. If you're interested in a problem where it has something like yearly payments with monthly compounding, you're going to want to check out the next video beyond this one for when they don't match. Starting off here with this example problem and the equation, we're going to be calculating the future value of $300 at the end of each year for 5 years if the APR is 6% with annual compounding. So first, let me draw out a timeline. Now, a few things to note is first, I added 5 cash flows on, and each one is happening at the end of each year. So for instance, this first $300 happens at the end of this first year. Keeps on going all the way across. So the last cash flow is received in t equals 5. Now, typically when we're looking for the future value of an annuity, we're looking for the future value in the year of the last cash flow. So we want to find the future value in year 5 of all of these cash flows. Now, if we were solving this as if it was a single cash flow problem, and we just took each one of these and brought it forward to year 5, we would do something like taking the first $300 and compounding it forward 1, 2, 3, 4 years at 6%. Then the next $300, we would compound it forward 1, 2, 3 years. And then you would keep on going across your remaining 3 terms. Now in this problem, that wouldn't take too long because there are only 5 terms, but you can think about something like a bond problem where you may have 30 or 60 cash flows going all the way across. Chances are you don't want to actually bring each one of those cash flows forward or backwards individually. What we can use instead is this future value of an annuity equation that's down here in the bottom left corner of the screen. What this does is it's going to tell us the future value in the time period of the last cash flow. And the different inputs we need are first, we need the repeating cash flow value. So that's our CF. So in that example problem above, that would be the $300. Then we need the rate between cash flows in decimal form. And I'll come back to that one in a second. And then lastly, we need our N, which is our number of cash flows. So the number of cash flows in this example would be 5. The one to pay attention to here would be this R value, so the rate in between cash flows. When the compounding frequency and the payment frequency match, this is going to be the periodic rate. So the periodic rate, what it's equal to is it's equal to the APR divided by the number of compounds in 1 year. So as we go through each one of these problems, we'll look at how this periodic rate actually ends up being exactly what the rate between the cash flows is. Now let me set up this first problem. We would end up with, using the numbers above, our cash flow is 300. We need 1 plus our R. I'm going to leave R blank for right now before we calculate it. Our number of cash flows is our N, so that would be 5, minus 1, divided by, again, our R. So if I calculate the periodic rate, I'm going to end up with my APR is 6%, and my number of compounds in 1 year is actually just 1. The reason it's just one is because it says annual compounding, right? So there's one compound per year. So my periodic rate here just ends up being 6%. That's the same as saying that in between each one of these cash flows is exactly 1 year, and my rate across 1 year is 6%. Now I'm going to put in 6% in decimal form, and I end up with the final answer here of $1,691.13. Now the way this equation is designed is this value that came out of this equation, right, is telling us in the time period of the last cash flow. So this value is in year $5, right? We took all these cash flows forward to right here. That is where it's giving us the future value of the annuity too. Now let's look at the next example. So here we're calculating the future value of $500 at the end of each year for 7 years if the APR is 4.5% with annual compounding. So again, what made it go into this PowerPoint, right, where everything matches, is that the cash flows are yearly and the compounding is yearly, right? So the frequencies match. Now on my timeline, I've drawn out 7 years, $500 at the end of each year, and we want to find the future value in the time period of the last cash flow, so time period 7. If I think about each one of my inputs, my repeating cash flow is $500. Next I'll do N. So my N is my number of cash flows. Here I have 7 cash flows. And then my R needs to be my rate between cash flows. Which ends up being the periodic rate. And the reason for that is because the payment frequency and the compounding frequency match. So my periodic rate is my APR divided by number of compounds per year. Which is 4.5%. And then again, this one's just annual compounding divided by 1, which gives me 4.5%. Last up, putting this all into the equation, I have 500 times 1 plus my R in decimal form. My exponent is 7 minus 1 divided by my R. My final answer here ends up being $4,009.58. So that is the future value in the time period of the last cash flow. Last problem we have here, we're going to take the same cash flow, so $500, but now we switched it to where it's at the end of each month for 7 years, and our APR has monthly compounding. So the two still match, just now they aren't both yearly. If I think about a timeline that's really kind of zoomed in here, that goes monthly, what I'm going to have is $500 each month for a total of 7 years. And now, thinking about what each one of my inputs is going to be, I need to figure out the R value that's occurring monthly, right? That R needs to be the rate between cash flows, so my R needs to be a monthly rate. Let's again do the inputs in the same order. So our cash flow is $500 per month. Our N is our number of cash flows. So we have 12 cash flows per year times 7 years. And now our R, because the compounding and payment frequency match, we need to solve this as the periodic rate of 4.5% divided by 12, which tells me that my rate is 0.375% per month. Right, I took an annual APR, I scaled it by the number of compounds per year. In this case, there were 12 compounds per year, right, 1 compound per month, and the monthly rate that came out of it was 0.375. So each month, the rate that the money is being reinvested at is 0.375. If I write out my equation, I'm going to have the future value of an annuity is equal to the cash flow. So 500, 1 plus my rate in decimal form, so I need to add zeros in front of that. My exponent is going to be 12 times 7 minus 1, again divided by my rate. The future value of this annuity ends up being $49,260.30. So all of these problems were where the payment frequency and the compounding frequency match. If that's the case, you want to use the periodic rate. If that isn't the case, that's what I'm going to be showing you in the next video, where you could have something like it's $500 at the end of each year, but with monthly compounding.